Hello students, we are solving numerical examples on Newton's second law of motion, right? So this is example number 3. See the statement. A 50 kg body is initially at rest on a 20 degrees inclined plane with coefficient of kinetic friction 0.25. Find the distance and the time the body travels before attaining a speed of 15 meters per second. So initially the block is at rest. It is kept on inclined plane of 20 degrees. Now you have to find out the distance travelled and the time taken by the block to attain a speed of 15 meters per second from 0, because initially it is starting from rest. So using Newton's second law of motion, first you can find out the acceleration, writing F is equal to m into a, and then you can use the equations of motion. Okay. So first let us draw free body diagram of the block. So FBD of the block. So free body diagram is the diagram showing all the forces acting on the body. So what are the forces acting on the body? Its mass is 50 kg. So there is a gravitational force which is acting vertically downwards, say mg. Weight is equal to mass into acceleration due to gravity. So it is kept on the inclined plane. So the inclined plane will offer a normal reaction which is perpendicular to the plane. I am saying it is NR. And there is a friction force. Coefficient of kinetic friction is given 0.25. So the block is moving down the plane. So the friction force will act up the plane. So the magnitude of friction force is coefficient of friction into normal reaction. Right? So what is the angle made by this mg with respect to normal? See here, it is given 20 degrees. So it is 90. Normal reaction is perpendicular to the plane. So 90, 20, and it is 70, and hence again here it is 90. Therefore it is 20 degrees. Right? Now resolving this mg into two components. One is perpendicular to the plane. The other component is parallel to the plane. So this component is making an angle 20 degrees with mg. So this component is mg cos 20. Other perpendicular component mg sin 20. So now I am taking x-axis along the plane and the y-axis perpendicular to the plane. So the block is moving along the plane. So it is not moving perpendicular to the plane. That means along y-axis. So the block is in equilibrium in y direction. So we can write summation Fy is equal to 0. Equilibrium equation in y direction. So it is plus Nr minus mg cos 20. So only these two forces are acting in y direction is equal to 0. So the normal reaction is equal to mg cos 20. So equation 1. And the block is in motion along the plane, that is along x-axis. So as per Newton's second law of motion, the unbalanced or the resultant force is equal to mass into acceleration. The resultant force in x direction is equal to mass into acceleration. So here mg sin 20, it is moving towards left. I am taking this is positive x-axis, negative x-axis. Minus mg sin 20, and this mu k into normal reaction, it is acting in the positive direction. So plus mu k into nr, right? Only these two forces are acting in x direction. So this resultant force is equal to mass into acceleration of the block. So it is minus m into 9.81 sin 20 plus mu k is given 0.25, and the normal reaction from equation 1, it is mg cos 20. So m into 9.81 cos 20 is equal to m into a. So taking m common, you can cancel. So solving this equation, you will get a is equal to minus 1.05 meters per second square. So this minus sign indicates what? We are taking this is positive direction towards right, and the negative direction is downwards. So we are getting acceleration is minus. That means the block is moving down the plane with an acceleration 1.05 meters per second square. Understood? Now once you know the acceleration, using equations of motion, you can find out the time and the distance traveled before it attains a speed of 15 meters per second. So I will rub the statement. So using equation of motion, v square is equal to u square plus 2as. V is the final velocity, which is 15 meters per second. It is given. You have to find out the distance traveled by the block before attaining a speed of 15 meters per second. U is initial velocity, that is 0. It is starting from rest. And A is 1.05 meters per second square. So the block is moving down the plane. All the quantities are in one direction only. So here 15 square is equal to 0 plus 2 into A is 1.05 into S. So this gives you S is equal to 107.14 meters. So it is the distance traveled by the block before attaining a speed of 15 meters per second. Now to find out the time taken, I will use the equation V is equal to U plus AT. So here V is equal to 15, U is equal to 0, A is equal to 1.05 into T. So this gives you T is equal to 14.28 seconds. So these are our final answers. The distance traveled by the block and the time taken to attain a speed of 15 meters per second. Understood? So we will solve one more example. Let us read the statement of the problem. The system shown in figure is initially at rest. Neglecting axial friction and mass of the pulley, determine the acceleration of block A. So initially block is at rest and a cable is passing over the pulley which is connected to block A, and at the other end 1000 Newton force is applied. And here we are neglecting the friction in the axle of the pulley and mass of the pulley. So the tension in the cable remains same throughout, right? Let T is the tension in the cable, which is equal to 1000 Newton. So let us draw free body diagram of block A. FBD of block A. So what are the forces acting on it? Mass of the block is given 200 kg. So the weight of the block will act vertically downwards, say mg, and the tension in the cable, it is upwards, and the magnitude is 1000 Newton, right? And the block is, say, moving in vertical direction. As per Newton's second law of motion, the unbalanced force or the resultant force in a vertical direction is equal to mass into acceleration. This is the acceleration of the block in vertical direction. So here it is plus T, that is plus 1000, minus mg is equal to ma. So it is 1000 minus mass of the block is given 200 kg. 200 into 9.81 is equal to 200 into A. So solving this equation, you get A is equal to minus 4.81 meters per second squared. Here, what is the meaning of minus? Minus indicates that the block is having downward acceleration A. So the acceleration of the block is 4.81 meters per second square, which is acting downwards. That means the block is moving down with an acceleration 4.81 meters per second square, right?